Hello friends, today we will discuss about HPLC. HPLC, its full form is High Performance Liquid Chromatography, and it is also known as High Pressure Liquid Chromatography because to pump the mobile phase we use high pressure pumps which to pump this mobile phase into the column. And what is chromatography? Chromatography is a technique used to separate a mixture, and liquid chromatography means basically we are using liquid as a mobile phase. I'll show you about instrumentation of the HPLC. HPLC basically contains a solvent reservoir in which we'll place our mobile phase, and this solvent reservoir is pumped into the column by a pump, and then will contain a constant temperature chamber in which column is placed. This chamber maintains constant temperature throughout the runtime, and next we will have a detector which detects the solute which is separated, and data processing unit which process the data. So in this I will show you from first. Solvent reservoir will place our solvent or mobile phase or any buffer in bottles. Usually it will be placed above the HPLC equipment. From this solvent reservoir, the solvent moves into degassers. So degassers, name itself it represents, that means the gases will be extracted out. From these degassers they will be connected. So you can see here these degassers are connected to a vacuum pump. The gas which is present in solvent will be pumped out of this mobile phase by this vacuum pump, and only pure mobile phase moves further. So the solvent from these reservoirs is pumped by this mixing valve pump, and this solvent or mobile phase further moves into constant temperature chamber. Here our solvents should get constant temperature before moving into the column. So to get constant temperature of our mobile phase, we have equilibration coil. This coil maintains the temperature of mobile phase, and our mobile phase temperature gets equilibrated in this coil, and further our mobile phase moves into guard column. This column acts as a pre-filter. So all the impurities which are there in mobile phase will get filtered by the guard column, and further the mobile phase moves through flow splitting valve. So mobile phase here divides into two ways. And this flow splitting valve is usually used so that the mobile phase moves to detector, and next same mobile phase it moves to sample injection port and column. Here the mobile phase which is moving directly to the detector, it is used as a reference by the detector, and next same mobile phase it moves to sample injection port in another way. Here the sample, whichever the analyte which we should separate, that analyte sample is injected into the mobile phase. So this mobile phase along with the sample is pumped into the column. Here the components of our sample will be separated based on affinity of our sample components with stationary phase. So this column it will be generally made up of tiny particles which are packed in this column. So in order to pump our mobile phase through this column we need high pressure. That's why we use pump here. And so my sample will be having different components. These components will have different affinities towards our stationary phase. Whichever component which has more affinity towards stationary phase, it moves slowly through the column. The component which has less affinity towards stationary phase, it moves fastly through the column. So component which has less affinity, it moves slowly through the column, and components which have more affinity, they move fastly through the column. So first I will get the these components which has less affinity towards stationary phase, they get eluted first and they will be detected by the detector. And the signals which are detected by detector are processed by data processing unit, and this processing data will be shown in the form of a graph, and this graph is known as chromatogram. Here in x-axis we have time, in y-axis we will be having sensitivity of detector. So initially I will get only mobile phase eluted out of this column. So the signal will be linear, straight line. So after some time the sample which is separated out comes out of the column and detector detects the sample. So slowly I will get the sample which is separated out, its concentration increases. At a point I will get complete separated sample out of the column. So here I will get peak of that sample, and again it moves down, and this graph is used to detect the sample, to qualitatively identify which is our sample, and to identify the amount of sample that is eluted out. So this graph is used to identify and quantify our sample. Why do we use HPLC? So it's used to separate components of mixture, also known as high pressure liquid chromatography. Since we know that we use high pressure to move our mobile phase through the column. The system involves pumping of mobile phase through the column under influence of high pressure. So following four methods are used to separate our components of the mixture. Adsorption, that means the solute particles, they just adsorb onto the surface of our mobile phase. This is our mobile phase. When the this is our stationary phase. When mobile phase is eluted through this stationary phase, that is column, the particles of solute, they get adsorbed onto the stationary phase. So whichever the solute particle which is having more affinity towards stationary phase, they stay in the column, and particles which have less affinity towards adsorption, they move along with mobile phase and they get eluted fastly. And this we can separate a mixture of sample by partition also. In this, the liquid is bound onto the stationary phase. We will have liquid as stationary phase which is bound to a solid. When we move the sample through this column, our solute particles, they get distributed between mobile phase and the bounded liquid. And by this, the solute particles get separated. Ion exchange. In this ion exchange, resins are bound to the stationary phase of our column. These ion exchange resins, they interact with the ions which move through the mobile phase, and the ions get separated like this. Exclusion. This exclusion chromatography, it is also known as size exclusion chromatography. Based on size of our sample particles, they get separated. So our column will be made up of beads, and these beads contain pores in them. When mobile phase is eluted through the column, the small particles in the mobile phase, they get inserted into these pores, while larger particles, they come out of the column fastly. Like this, our sample components will be separated. Analytical column is packed with small particles of stationary phase. So our column is made up of small particles. Usually it will be silica. These particles are packed tightly in this column, and this is known as a stationary phase. High pressure is applied to pump the mobile phase or liquid phase through the column. High pressure is applied to pump mobile phase or liquid phase through this column. Different materials are used to make this column based on different principles. We will see one by one. Adsorption. In adsorption chromatography, we will use octacylene or alumina to make the column, and these are commercial names. Particil C2 made up of octacylene, it is porous in nature. That means the column will be having small pores in it. Pelumina, it is made up of alumina, and it is pellicular support. The center of the column will be having solid support, around which the porous particles are packed. This type of column is known as pellicular. Next, partition principle. Example of this column is Bondapac C18. It is made up of octadecyl selene. It is pellicular in nature. Ion exchange. In this, the polymer of ion is embedded onto a solid inner column. These polymers may be strong base or weak base or glass. Strong base, that means the stationary phase whichever we use in ion exchange, it won't change its charge even when we use a mobile phase which is having varying pH. For example, sulfonic acid SO3H. When this sulfonic acid is used, it is generally a strong acid. When it is used in the column, the charge of the sulfonic acid will be same even when we pass mobile phase which is having different pH. Next, weak base. These bases, they change their pH, they change their charge when the mobile phase has varying pH. Next, glass. So around these glass particles, a polymer will be coated which will be having ion exchange functional group, charge functional group on this. These glass pieces, they will be packed in a column. They contain polymer which will be having charged functional groups. Next, exclusion. Polystyrene divinyl benzene. It is so commercial name is Styragel. It is a semi-rigid gel. Agarose, commercial name is Sucrose. It is a soft gel. The separation of solute takes place based on physical and chemical interactions between packed material and solute intended to be separated. So our solute gets separated in the column based on physical and chemical interaction. So component which has more attraction towards stationary phase, it moves slowly, and component which has less attraction towards stationary phase, it moves fastly and gets eluted out of the column along with mobile phase. The inert column used in HPLC acts as a sieve and sorts the components retained from the column based on size and distribution of components along the support. So this column basically which we use in HPLC, it is inert and it acts as a sieve which separates the components of sample. High pressure applied on the solvents flowing through the column enables the use of solid packed support. So the column in which the solid packed support which acts as stationary phase, it is packed tightly with small particles. So to move the mobile phase through this column, high pressure is used. The application of high pressure, it also reduces run time. The time which requires for our mobile phase through the column to come out after injection. This time is very low in HPLC. Retention time. The time required for emergence of maximum peak of component after injection is known as retention time. So when a mobile phase is injected into the column, some solute particles get separated. The particles which have less affinity towards the stationary phase, they get eluted fastly. So I will show you in the graph. So at the starting point, I inject the sample into the mobile phase. So initially only mobile phase comes out of this column. So detector detects only mobile phase. So when only mobile phase is getting eluted of the column, we get only baseline. This is the baseline. And after some time, the sample gets eluted out of the column. This eluted sample is detected by the detector, and the absorbance in the UV visible detector increases. So as more and more solute gets eluted out of this column, the peak increases. We get a peak. And when the maximum amount of solute is eluted out of the column, we get maximum peak here, and again it goes down. So the time required for formation of this peak is known as retention time. To form this peak, the solute should come out of the column and gets detected by the detector. So the time required for the solute to move out of the column is known as retention time. So the time required for emergence of maximum peak. So after complete emergence, only then we will get maximum peak of the solute. For emergence of maximum peak of component after injection is known as retention time. So this retention time, it is the sum of time that the solute spends in stationary phase and mobile phase. So retention time is sum of time the solute component spends in stationary phase and mobile phase. Adjusted retention time. So it is the time duration that a component spends in stationary phase. That means the time duration that component spends only in stationary phase, not the mobile phase. So this is equal to retention time minus time the component spends in mobile phase. So retention time is total time that the component spends in the column. And if we need to get the time that solute spends only in the stationary phase, then we should subtract the retention time from the time that the solute spends in mobile phase. So Tm is the time required for retained substance, unretained substance to elute from the column. So unretained substance, that means these substance do not have any kind of interaction with the stationary phase. They get directly eluted out of the column without any interaction with stationary phase. So this time is known as Tm, or else it is also Tm is also equal to time for mobile phase to get eluted out of the column, to pass through the column. In HPLC setup, apparatus operate efficiently with low tolerances. We will get the result efficiently. The correct efficient result will be obtained in HPLC and with low tolerances. That means if my result is result of my standard substance is 5, and when I get the result of sample, it should be in a limit 5 plus or minus 0.5. So this limit should be less. So in HPLC we will get the result with low tolerances. That means I may get result in 5.2 or 5.5. So I will get result in very less limit. Next, the mobile phase. Mobile phase is made up of mixture of polar and non-polar components. So the mobile phase I can use, for example, I can use petroleum ether. I can use it to elute the solute, or else I can use a mixture of chloroform and water. Here the chloroform will be non-polar in nature and water will be polar in nature. Like this, I can use mobile phase made up of mixture of polar and non-polar components. The component ratio of these liquids depend on sample composition. So based on composition of sample which should be separated, I use the polar and non-polar liquids in a certain ratio. Degassing. It removes the liquid dissolved gases in solvent or mobile phase. So we have seen, as we have seen initially at first during instrumentation, degases, they remove dissolved gases from solvent. These degases will be connected to a vacuum pump which pumps the gases from the solvent. Column. Here components are separated accordingly to the differing interactions with column packing. When analyte moves through the column, they get separated according to their interaction with the column. And these separated components, they will be eluted out of the column. If the interaction with species and stationary phase is weak, it spends less time in the column. So when the solute components have less interaction with the stationary phase, these components get eluted fastly along with mobile phase, and so the retention time will be less. Homogeneous column. Here that homogeneous means throughout the column we will be having constant stationary phase packed. Silica or alumina are packed in stationary phase. Bounded column. Here we use liquid as stationary phase. The liquid will be bonded to a solid support inside the column. The solute components gets distributed between liquid stationary phase and mobile phase. Pump. Pump is used to introduce solvent and sample into the column. To introduce solvent and sample into the column, we need pump here because we know that our column is packed with solid. And it maintains constant pulse free rate. So the force at which the mobile phase is pumped into the column will be constant throughout the runtime. HPLC pump can be multi-piston or syringe type. That means many pistons are used to pump the solvent into the column, or else it may be a syringe type. So it will be similar to a syringe in which this plunger, it is attached to a motor which pulls and pushes this plunger so that the mobile phase will be forced into the column. Detector. At column end, at the end of the column, detector will be present. So these detectors, in HPLC we use UV absorption detector or NMR detector. It registers the presence of components in the sample but not the solvent. So these detectors, they only recognize the sample components but not the solvent components.